Good day everyone, my name is Raluswinga Hulisani. Today I will be your maths tutor. I'll be doing mathematics paper 1 revision, wherein we'll be focusing mostly on topics such as algebraic, number pattern, hyperbola, and inverse function. Let's start with algebraic questions that is mostly found in question 1. Let's start with question 1. Given that we have function f of x is equals to x squared minus 3x minus 1 close brackets open brackets x plus 2. We were told to solve for x. Our f at x, we're given that it's 0, then x squared minus 3x minus 1 x plus 2. Then we have to write it as follow: x squared minus 3 is equals to 0, equating everything to 0. 3x minus 1 equals to 0. X plus 2 equals to 0. Here we have x squared is equals to transposing this negative 3 to the other side being positive 3, then square root it to get rid of this square. X equals to plus or minus square root of 3. Then we have 3x, which is equals to transposing this negative 1 to the other side, making it 1. So x dividing by 3 because we don't want 3x but rather x. 1 over 3 x will be equals to transposing this 2 to the other side, negative 2. So we have solved everything. So now, like 1.1.1, it states that solve for f of x, solving x where x is an integer. Remember that an integer is whole number, whether it's positive or negative, but then it does not have to be a decimal or a fraction. So in this point we have this one, x equals to plus or minus root 3. This one will be a decimal, and also this one will be a decimal because it's 1 over 3. Then we are left with x equals to negative 2. So our answer for 1.1.1, here x will be equals to negative 2. So 1.1.2, let me write it here. It says that when x is a rational number, remember that a rational number, it has to be in decimal or a fraction. We have these two here, being that our x will be equals to 1 over 3, or x will be equals to negative 2. 1.1.3, it states that when x is a real number is any number that is found in a number pattern, meaning that this one also fall in the number pattern, also these two. So our answer for 1.1.3 here would be x is equals to plus or minus root 3, or x will be equals to 1 over 3, or x is equals to negative 2. So we are done with 1.1. Let's go to 1.2, wherein we have to solve for x given a problem as follows. We have negative 15x squared minus 9x plus 4 is equals to 0, and we were given an alternative that it has to be in correcting to 2 decimal place. We have to use this formula because it will be difficult for us to find the factors at this point. Using this formula, minus b plus or minus the square root of b squared minus 4ac divided by 2a. Remember that we have a, that it will be equals to negative 15, b will be equals to negative 9, and c will be equals to 4. So most of the time you will find learners like forgetting to put this sign, saying that maybe an a, our a would be 15. No, you don't have to be like, you have to take also the sign of it. So let's proceed with our substitution, where in b we got negative 9 plus or minus the root of negative 9 squared minus 4 into our a is negative 15 and positive 4, all divided 2 into negative 15. So let's punch on a calculator. Our first will be negative 0.09, or our x will be equals to 0.30. Now we are done with 1.2.2. Let's focus on 1.2.2, given a problem as follows. Three x minus 2 all to the power squared greater or equals to 3x. So I will first do expand. Let's expand here. 3x minus 2 greater or equals to 3x. Using FOIL method at this point, this multiply this, then multiply this, and this multiply the other one. 3x multiplied by 3x, that's 9x squared, and that will be 2x, negative 2 and negative 2, then positive 4 greater or equals to 3x. So at this point we have to transpose this 3x to the other side, given it like 9x squared minus 12x plus 4 minus 3x because we've transposed it to the other side, greater or equals to 0. So here we have 9x squared minus 15x plus 4 greater or equals to 0. And before I forget, you'll find that learners changed the sign here. We only changed the sign here at the final stage, not anywhere near where we are still finding which x are we supposed to get. So when you get factors for 9x squared, we have 3x. Then from here, we have to find factors of 4, which is 4 and 1. Because here is positive, both of them, they have to be positive. And here, they have to be negative because here is positive. So our first x will be greater or equals to 4 over 3, or x will be less or equals to 1 over 3. So here the trick part that I want to tell you is that the one that takes the sign that we were using is the one that has the highest. I'm sure I'm understandable on that one. So let's continue with our problems. Let's go to 1.2.3. Given that we have 5x, 5 to the power of x, which will be equals to 5 into 4 plus 5 to the power 2 minus x, then close brackets. We have to solve for x. Firstly, let's get rid of those brackets. 5 to the power x, which is equals to 5 multiplied by 4, giving us 20. Then plus 5 multiplied by 5 to the power 2 divided by 5x. This 5 to the power is this one. It being positive, we have to divide it by here. So for here, let's use the k method, letting 5 to the power x to be equals to k, for us to have a simpler way and not be confused whether our x is at the power or. So x is equals to 20 plus, here it's 5 to the power 1 multiplying with the same base, we add the exponent, and 5 to the power 3, that's 125, divided by k. Let's multiply here by k, multiply by k, multiply by k. K squared is equals to 20k, then plus 125. Let's take everything that is here to the other side. given that we will be having 2x squared minus 20k minus 125 equals to 0. So let's find vectors. We have k and k here. Let's put 25 and 5 this side, positive here, and negative on this side. So our x here would be equals to 25, or k would be equals to negative 5. Let's substitute back the 5 to the power x on the k. 5 to the power is equals to, making it a power here, 25, it's 5 to the power 2, or on the other side we have x to the power 5 to the power x, which will be equals to negative 5. Therefore here x will be equals to 2. So on this other side we know that we have 5 here and 5 here, but then they are not the same because of the sign. So we can equate saying that, okay, therefore x is equals to 1. No, that won't be possible. It can't be, because of the sign that we have at the denominators, I mean at the base. So let's continue with our problems. Mm, 1.3 we are told to, or it says, solve for x and y given that we have log base x 16 is equals to 4, and y plus root of x plus 7 is equals to x plus 1, like this. So let's focus here because this one is simplest. It only have an x only, does not have a y. So getting back this thing into a power, we go it like this. This base will always be the same. It will be x to the power, because we are going this way, to the 4 and equals to 16 to the 4th power equals to 16. And we know that for 16 to have a 4th power, it was as follows: is 2 to the 4th power, giving it as 16, like this. So therefore our x will be 2 because of the same base, just like that. So we have to substitute in this other equation. So in this other equation state that y, we are substituting by the way. Here is 2 plus 7 is equals to 2 plus 1, y plus square root 2 plus, that would give us 9, equals to 3. So square root of 9, that's 3, it will be equals to 3 this side, y is equals to 3 minus 3, therefore our y would be 0. So therefore x is equals to 2, y is equals to 0. We are done with that. So let's go to 1.4. 1.4 state that calculate two numerical values of p so that, let's write this equation down. X squared plus p, open brackets, 2x plus 7, then plus 8 is a perfect square. For a perfect square, remember that for a perfect square we have a formula. Our formula for a perfect square is delta p is equals to b squared minus 4ac. So let's start this side so that we can get rid of these brackets. X squared plus 2px plus 7p plus 8. Look here, we have this, that will be our c. Here it's a, and here that's b, and our coefficient will only take the coefficient of the x squared or x. So let's start. Our a in this point, it will be 1, b will be 2p, and c will be 7p plus 8. I hope you understand by that. So delta is equals to, on b squared we know that we have 2p squared minus 4a is 1, and c is 7p plus 8, like that. So here it will be 0, 2 to the power, that's 4p squared minus negative 4 multiplied by 4p, that will give us negative 28 p, then negative 4 2, that would give us negative 32. So let's divide here by 4, divide here by 4, divide here by 4 to make our life easy. Then p squared minus 7p minus 8 is equals to 0. Here let's look, let's find factors of 8. That's when we add them, they give us negative 7. We have 8 and 1 itself, like this. So to get this one, it's when here it's negative and here it's positive, like this. So p will be equal to 8, or p will be equal to -1, like that. So we are done with question 1. So let's proceed to number pattern that you will always find on question. You will always find on question 2. We are given a sequence. The following sequence of numbers form a quadratic pattern. We are told that the sequence that we are given is a quadratic pattern. You know the formula for quadratic pattern, but then let's not jump into conclusion. Okay, -3, -2, -3, -6, -11. So let's first find the difference here. -11 minus -6, that's negative. So -6 minus into -3, that will be -3. -3 minus into -2, that's -1. Remember that when it's from here to here, it's -11 minus into -6, like this. So let's proceed. -2 minus into -3, -2 plus 3 is like -3 minus 2, that's 1. So this is our first difference. This is our first difference. And remember that our first difference always gives us an arithmetic or linear pattern. So let's come to our second difference. Our second difference like this. So let's answer the questions. It states that 2.1, it says that the first difference of the given sequence also form a sequence. And I told you that it also form a sequence of arithmetic. So it says that determine an expression for the nth term of the first difference. By the nth term, they mean the general term. So 2.1, and the general term for 2.1 for the arithmetic is Tn is equals to a plus into n minus 1, then d, and our difference we know that is -2, and a is 1. So here it will be 1 plus into n minus 1, then here it's -2. So 1 -2 multiplied by n, that's -2n, -2 multiplied by -1, that's +2, -2n plus 3, because it's 2 plus this 1. So this is our nth term. So let's continue. It says that calculate. Okay, we got the n term as negative 2n plus 3. Sorry about the rain, it's raining this side. So it's 2.2 state that calculate the first difference. Okay, so 2.2.2 it states that calculate the first difference between the 35 and 36 term of quadratic sequence. I think they mean quadratic sequence using this formula. The end is, we will use 35 negative 2 into 35 then plus 3. So our t 35 will be equals to negative 67. So let's go to question. Let's go to 2.3 where it says that, let me first write our sequence: negative 3, negative 2, negative 3, negative 6, and negative 11. We found the first difference: negative 3, negative 1, and 1. Here we have negative 2 being our D, negative 2. So remember that our formula for the general is Tn. Me right here is Tn is equals to an squared plus bn plus c, like this. So to get our a, we will use 2. Here is 2a equals 2. For this here, it's 3. It's 3a plus b, which is equals to this one, and here it will be a plus b plus c, which will be equals to the first term. So let's find a, given that is 2a is equals to negative 2 divided by 2 divided by 2. Our a, it will be negative 1. So to get b, we will use this formula: 3a plus b is equals to 1. We already got our a being negative 1 plus b is equals to 1. Then b is equals to 1 negative 3, transposing to the other side, and it will be 3. Then our b is equals to 4. So let's go to find c using the formula a plus b plus c is equals to negative 3. A is negative 1, b is 4, plus c, which is equals to negative 3. Here that will be 3 plus c equals to negative 3. Here C is equal to negative 3 minus 3. Then our C is negative 6. So therefore we can conclude that our general term is gonna be negative n squared b plus 4n minus 6. So let's continue. 2.4 state that explain why the sequence will never contain a positive term. Okay, when we look at this sequence, remember that it will never be a positive term, I will say, because of this difference. Or here, this will state that whenever it is given, it will never be a positive, and here for the difference. So let's continue. Question 3. It's a hyperbola. And remember that whenever we are dealing with a hyperbola like this, there has to be an asymptote. Our formula being x is equals to a over x plus p then plus q, like this. So whenever we have to, this will be our x asymptote and this will be our y asymptote. So to get our p, because here at 4.1 it says that write down values of p and q. To get p, we have to use this formula. Always use this formula. X is equals to negative p, like this, and we have this x here given that it's negative 2, which equals to negative p, divide here by negative 1, divide here by negative 1, then our p will be equals to 2, like this. Then for q, we'll write it like that because it's our asymptote, negative 1. So 4.2 says that calculate the value of a. Let's calculate the value of a, given that we have p and q already there, and also we have this here, it being negative 4 is to 5 over 2. So we have our formula written like this: a into x, remember that we already have p, plus 2, then minus 1. Let's substitute our x and y. This is our y, this is our x. Here we have 5 over 2, which is equals to a over, for x it's negative 4. Here it's negative, by the way. Then plus 2 minus 1. Transposing this to the other side, it will be like this. Negative 5 over 2 plus 1 is equals to a over negative 4 plus, that's negative 2. taking it to the other side. Therefore, we'll find that our A will be equals to 3. So let's write down our formula in full. Therefore, f of x will be equals to 3 over x plus 2 minus 1. They didn't tell us to write the formula, but then I'm just writing it for you so that if ever a question comes saying that you have to write the general formula, the formula for f of x, you'll know how to write it. So let's go to 4.3. It states that write down the range of f. Remember that whenever we talk about the range, we are talking about the y values. So in this case, for our y, it will be every value of y being written as y is a real number. But remember that we have an asymptote that is -1. Y will not be equal to -1. Here, y is an element of real number, but our y should not be equal to -1. So let's go to question point 4.2. It says that determine the equation of the line of asymptote of f for m being greater, for m being less than 0 in form of y. So in the form of y, they say that we have to write it like this. Line of asymptote is the same as when we are saying let's write the line of like this. So our y being that our m will be equals to -1 because it's cutting there. So our y minus -1 equals to -1 x minus into -2 like this. Therefore our y will be -x minus 3 like that. So let's go to question 6. Our question 6 is the inverse. Whenever we are dealing with the inverse, know that we have to have some of the equations that will be the inverse and everything along the way. So like the sketching, how you can sketch, you have to know how to sketch an inverse graph, how to determine the values that will be, but then we'll know for a fact. So we are given f of x is equals to 3 to the power x, and it says that determine the equation of the inverse of f in the form of the inverse of a, in the form of sorry, in this format. But first, let's deal with this. We will write it in this way. 3 to the power. And remember that I told you that this base will always be an inverse of an exponent. It's a log. We have to introduce the log, but then we have to interchange. X will be equals to y to the power, 3 to the power y. Therefore, y is equals to log base 3x, like this. So therefore here will be log 3x. So 6.2 states that sketch the graph of f and f in it says sketch the graph of f and its inverse. You know how to draw the graph of, being that here will be 1 and here will be 1. If, for example, that will be our graph of f, and the inverse of it has to be in this way. Always know that if ever here it cuts at 1, here it will cut at 1 also. This is the inverse. And 6.3 says that write down the equation of line of symmetry between the two graphs. The line of symmetry between the two graphs is around here, and we know that this line here is called y equals to x. So if our graph will interchange maybe from this side to that side, having that this will be our line of symmetry and it will be y equals to negative x. Always remember these lines of asymmetry. Know these lines of asymmetry. So 6.4 says that for which values of x will f of x multiplied by be less or equals to 0. That will be when the values of x is greater or equals to 1 or like this. So 6.5 says that write down the range. Our range, we know that whenever we are dealing with the range, we are dealing with what? With values of y. Range y, domain x, range y, domain x. So here it says that the range of h of x minus, that will be y, that will be greater than 4. So 6.6 says that write down an equation for g if the graph of g is the image of graph of f after f has been translated 2 units to the right and reflected above the y-axis. Okay, when it is reflected above the y-axis, meaning our f of x is like this, and here it's shifted, here it's reflected, but then it says that we have to write down, because our f of x, it was like this, is equals to 3 to the power x, and it says that it has shifted, meaning it shifted and here. So our g of x would be equals to here negative 3x minus 2, like this. So for your exercise, I have constructed question 1 that will be dealing with algebra. Then this one, it's pattern, and here we have our hyperbola, being that here it's the x asymptote and y asymptote, and this is our inverse function. So thank you, and please like and subscribe. We'll meet on the other video where we'll be dealing with paper 2, or rather paper 1, the rest of the topics. Thank you.